EEVS is a provider of measurement and verification services, particularly for energy performance contracts. And I should perhaps just start by saying that it's not always strictly smart metering that we're able to get for some of these projects until perhaps a bit more recently. But there has been a really notable increase in data coming from automatic meter reads, particularly for the smaller non-domestic buildings, and also very much so for gas data, that if you sort of go back 5, 10, 15 years, wasn't really there. But I think that the lessons from using this data are very much applicable for what we could get out of smart meter data. So yeah, if we go on to the next slide, I can just set out a bit about the context of sort of energy performance contracting in the UK. And I suppose just by energy performance contract, I mean any sort of project that's got some aspects of guaranteed performance, however that might be structured from a technical or commercial point of view. And just sort of looking at the reasons why organisations are interested in performance contracting, and this is not by any means a sort of comprehensive list, but I guess some of the key things we find is that people want to outsource, or organisations want to outsource technical risk, but also the risk of the guarantee and the performance itself. So the supplier takes on basically the risk of getting the project right and making sure that it's delivered effectively. It also sort of opens up access to more finance, which in turn kind of increases the viability and scope of some of these projects. So kind of enables the end user to procure a more holistic solution, do something that's a bit further reaching rather than kind of procuring technologies piece by piece, starting with those with the lowest paybacks. So yeah, it does mean that we can have some more ambitious and ultimately sort of more capable of saving energy and I guess other sort of carbon metrics. And then I guess the other thing for the UK is that there are several public sector frameworks already available that are quite well established now, and that means that it's more easy for local authorities and other public sector bodies to access these projects and procure them more easily. And then thinking about what makes for a good performance contract, again, not a comprehensive list, but I guess starting with suitable buildings, and a really important part of that is the quality of the data, particularly in terms of assessing the opportunity in the first place. It's very difficult to do that without good data. We want the savings to be achieved, which should sound fairly obvious, but we also want that success to be communicated clearly and transparently, i.e. measured and verified. And again, we can't really understand the savings without access to reliable energy data. So again, that's sort of very much a common theme within this. If we go on to the next slide and just have a quick, I guess, look at measurement and verification and the sort of the best practice standards around that. The International Performance Measurement and Verification Protocol is our sort of reference document for measuring energy and water saving technologies. It sort of sets out good practice principles and methodologies, and I'm sure it might well be sort of familiar to people listening to this session. But I guess, yeah, the key thing to point out is that the difficulty around measuring an energy saving is that, of course, you can't do it directly. You can measure what you did use, and you need to compare that to what you would have used, and there kind of in lies the challenge, really. What you would have used had you not done the scheme could be quite complicated to work out, and that's why there is value in having an input from qualified professionals, and by the same token, third parties where there's I guess, a particularly large value at risk, which is, I guess, the role that we fulfill. And then on the next slide, just looking at the process, and particularly, I guess, where data comes in. So good practice process, as described by IPMVP, can be sort of thought of in two stages: the baseline period and the reporting period, and very crucially, the baseline period happening before you've actually implemented anything. And that I can't really emphasize enough how crucial that is to plan in advance of implementing measures, when it comes to being able to reliably measure them afterwards. So in this slide, we've got our baseline period where IPMVP will define a number of activities, And very much amongst them is the assessment of what data is required, what calculations need to be applied to that data, an assessment of its accuracy, etc. And making sure that having it and collecting it properly is then set out for the duration of the project. And then the second stage, the reporting period, that will happen at a defined point after implementation, and generally a case of gathering the data that was specified in the baseline stage, at the first stage, and then applying whatever calculations we specified, which perhaps maybe sounds like it's trivial, but we often find that projects may fall down to a lack of data availability, basically a lack of evidence, rather than necessarily a technical failure. And then just on the last slide from me is an example. Hopefully the next slide, if we can get that one up. That's great, thanks. Is an example from a sort of a typical chart, really, from an energy performance contract that's using a whole facility building approach. This sort of happens to be one building from a scheme with lots of different buildings in it. And the main intervention that we were looking at here is actually good energy management practices. So what are shown as optimizations on this chart are actually the results of site surveys identifying areas where basically tweaking things like hours of operation or temperature set points and that sort of thing, rather than sort of capital works. But so this is kind of showing what the process looks like with some real world data. We've got our baseline period prior to the project. That's our sort of red data. And then the approach taken is to build a mathematical model that responds dynamically to our sort of known changes, such as occupancy and weather. That's our blue line over the top. And so then you can see that by extending that model over the reporting period after we've done some optimizations, you see this gap opening up between the model and actual consumption, so that giving us our reported savings. And I suppose, yeah, so just to kind of a final note, really, to reiterate the value of good data at every point of these projects. So being the first thing to review when it comes to setting up a scheme, determining the savings in the first place, identifying the opportunities, making sure that we've got the possibility to build an accurate enough baseline, which then becomes absolutely essential in demonstrating performance. And I suppose also over time, developing an understanding of the buildings, providing insight that you kind of need for the sort of transformative impacts that we're looking for. And as I said at the start, the growing use of AMR data and, by analogy, smart data has allowed this type of more impactful scheme to be applicable to a much wider range of buildings, and hopefully even more so as time goes on. Thanks very much.